Our universe might not have a start. For a really long time, we put stock in the hypothesis of the Big Bang. But now real observations of the early universe show us something totally different. Behind the Pandora galaxy cluster, the James Webb Telescope has found a baffling structure so old and so large that it could never have existed in a young universe. This gives us more proof that our hypotheses about the Big Bang and the age of the universe are wrong. There may never have been a beginning. The idea that something could have no start and no end raises questions for many of us. We are accustomed to thinking in spatial dimensions where things and cycles have a beginning and an end, or limits. Scientists also struggle with infinity because it presents unsolvable mathematical problems. Scientists can only work out quantities of length, height, and width within a defined space. If our universe is truly infinite, then it has no length, no width, and negative length in fact. Anyway, most of our current theories about the beginning and evolution of the universe rely on measurements that assume space is closed in some way. Since the James Webb Space Telescope has given us more and more evidence that the previous explanation of the universe's evolution is incorrect, other theories are becoming more likely. Toward the dawn of mankind, astronomers had theorized that galaxies, which appeared to be already billions of years old, would show signs of an early stage of development. They also expected to see the first bright stars from the first generation through James Webb. But here too, there has been no sign so far. All we see are structures that look so old that the Big Bang could never have occurred 13.8 billion years ago. What's behind the Pandora cluster? In February 2023, NASA released another deep image from James Webb. Here, we see the Pandora cluster, also called Able 2744, with the nascent merging of three massive galaxy clusters visible in the foreground. This remarkable discovery was made possible by Webb's near-infrared camera, NIRCam. Webb uncovered individual areas of the cluster for up to 6 hours, and then perfectly combined the new deep image from 5 individual images. The picture shows around 50,000 light sources, the oldest of which are thought to reveal further secrets of the early universe. There's more to this picture than just another stunning showcase of our telescope's technology. The massive cluster acts as a unique gravitational lens, magnifying all objects behind it. Due to the curvature of space-time, the ultra-deep close-up view, and the near-cam observations before the APO, epoch of reionization, program, or reveal for short, is responsible for this picture. Scientists investigated each hint of light in the image and noticed something that again calls our standard models of cosmology into question. Behind the cluster, a structure became visible that is so large and massive that it is incongruent with our previous scientific models of the early universe. Reveal has actually set itself the goal of capturing the first light signal from the APO of reionization. At that time, the universe is said to have been largely dark. However, the picture again shows that some of the points of light are probably galaxies that are over 13 billion years old, which means they are far older than our explanations. A massive surprise. This picture adds to the mystery of astronomy. The preliminary measurements showed a redshift value of Z equals 7.9, meaning the object had already existed about 650 million years after the Big Bang. The structure could be a proto-galaxy cluster. But how could massive galaxy clusters have formed 650 million years after the Big Bang, if at that time there were supposedly only isolated first stars or protogalaxies? So, the old theories are once again being tested, and this discovery increases the likelihood of a much older or infinite universe. The photometric near-cam data from the image has now been made available to many global research groups, and space scientists around the world are now working together to uncover the truth. What if the Big Bang never happened? It's astonishing. We are currently facing more possibilities in cosmology than we have in a long time. Before the telescope was launched, scientists were actually expecting the long-awaited confirmation of their theories. But now entirely new scientific dimensions are opening up. We will soon experience changes. What could this mean? We may soon be able to look even further back in time. And if we still can't find any signs of an early universe 14 billion light-years away, we will at least know for sure that our universe must be much older than previously expected. This wouldn't yet be proof of infinity, but this possibility would become almost certain. Again, let's investigate what supports this. The uniform distribution of the cosmic microwave background radiation across the whole sky shows that the universe is homogeneous and isotropic on a large scale. Both can be interpreted as signs of a vastly expanded universe. The Hubble Space Telescope also showed us that the universe has a flat geometry. Some scientists have also interpreted this as a possible sign that our universe is infinitely stretched out in every direction. A universe without end. There's another reality we must not disregard when considering the topic of the infinity of our universe. No one has yet found an end to the known universe. We observe over 90 billion light years, but there is no evidence of an end. Thoughts about the edges of the universe have so far been purely intellectual exercises, but not proven facts. James Webb's discoveries now suggest that there is no beginning on the timeline either, demonstrating a limitless universe. Proving infinity will be difficult, because even the best telescopes can never show infinity. Regardless of whether we one day travel through space in spaceships, we could never know for sure that it has an end until we find it. What might an infinite universe mean? It sounds fascinating to live in a universe that goes on forever, has no beginning or end, and has always been there. Only our science runs into problems with this idea. There are many unanswered questions. Previously mentioned issues of portraying such a universe deductively and precisely. Boundlessness would imply that we are probably not going to succeed in doing just that. We can explore partial regions and make inexact predictions as to which forces are operating there and where they come from, but the totality of the boundless universe would probably escape numerical and logical perception. Who says that we need to measure and experimentally explain every single aspect of the radiant universe? We need to ask ourselves why we are so carefully seeking this information and understanding of the universe. It's because we are searching for answers about our own origins. Where did everything come from? Who made it? And what is it doing here? Inherent science attempts to explain these questions with formulas and computations, and is now reaching its limits. However, liberal scientists also view the new discoveries as an opportunity to learn more about the universe in a completely new way. These discoveries might enable us to reach new levels with our exploration. So far, we need to admit that despite numerous theories and telescopes like James Webb, we still know very little about the universe. The infinity of the universe could also imply that we are in a kind of time-space loop, or in a well-crafted holographic projection. This would mean that we need to advance our consciousness and brains to understand the true essence of the universe. Might we ever reach the truth with a quantum computer? Now we come to an interesting section in the study of the universe that could genuinely be a revolution. Quantum computers. These machines may soon be so powerful and intelligent that they will provide us with answers to all the questions without us searching for long. These fascinating machines use the principles of quantum mechanics to process enormous amounts of data or perform complex computations. Quantum computers use qubits, which, unlike the bits of traditional computers, can not only take the values of 0 or 1, but also superposition states of these values. As you might know, qubits can join all possible outcomes and only collapse into a definite state when they are measured. This behavior shows that quanta theoretically contain all possibilities. What if we could access this information of the universe? We just need to figure out how to decipher the quantum language and program the technology, so it gives us answers that go beyond observational possibilities and traditional mathematical estimations. We must address the issue of the incompatibility of Einsteinian physics with quantum mechanics. So far, only string theory exists to bridge the gap between the two. But we can't prove string theory because it involves imperceptible dimensions. There are now countless versions of string theory, and none of them are fully compatible with a quantum computer. Such a computer could accommodate this data and show us our mistakes in an extraordinary way. It could also fill existing gaps and confusions with conscious computations. We could even combine quantum computers with artificial intelligence, and then we would likely have access to almost infinite knowledge. Telescopes would then be another fun way for us to observe the beauty of the universe, but we would no longer need to piece together what we see into a huge puzzle. Scientists predict that even the simplest versions of quantum computers will be able to show us, potentially, whether dark matter truly exists. So far, we have used the assumption of dark matter to explain irregularities in the movement of galaxies, but its existence has never been proven. A quantum computer could provide us with different types of explanations for the phenomena we have so far explained with dark matter, and also show us whether the concept of dark matter is real or a mistake. The primary models of these computers are already being used. However, the engineers are still having issues with the responsiveness of these advanced machines. Quantum computers are incredibly sensitive to vibrations and are only operated in specially sealed and protected rooms. Cooling presents a further challenge. Essentially, these processes are just an evolution of the enormous computers that existed in the 1960s and 70s. Today we have small laptops and cell phones. People who worked with the original massive computers could never have imagined that in those days. Nevertheless, it only took years for computer technology to progress to the point where it is now in nearly every household. Today, subscribe now and look forward to upcoming video hits.